Converting logarithmic and exponential equations. So in our previous video, we talked about the loop-de-loo method. The loop-de-loo method is how we can convert something from its logarithmic form into its exponential form, or from its exponential form into its logarithmic form. And the big idea is start at the base, across the equals, back again. This is the big important statement, and there's nowhere on this page to put that, huh? I'll just make it super tiny. Beautiful. Start at the base, across the equals, back again. So when we're going in the direction of taking a logarithm and changing it into an exponential, what we're looking to fill out is this. Blank raised to the blank is equal to blank, and we fill it in that order exactly. The important thing to know is that the base is always the first thing you fill out. That's why we start at the base. Start at the base, across the equals, back again. So I'm looking to fill out blank raised to the blank is equal to blank. So start at the base. The base is 2. So we have 2. We have just filled in this box right here. The next thing across the equals is a 3. So 3 goes in that exponent box. It helps if you've memorized that logs output an exponent. Logs output an exponent. So the output of a log is the exponent. And then we go back again. So this is equal to 8. 1, 2, 3. And that's our answer. There it is. Yay. Bam. Okay. What if there's no base written? Well, no base written means that it is a base 10. So we'll just put a 10 in there. This is one of our special bases. So we'll start at the base. Base is 10. Across the equals, raised to the 7, and back again is equal to x. So the statement log base 10 of x is equal to 7 is the same statement as 10 raised to the 7 is equal to x. Here we have ln. So ln is our natural base. So if you see ln y, this is log base e of y. ln is log base e. So I'm going to rewrite it as -5 is equal to log base e of y. E, remember, is that natural number. 2.71, blah, 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 goes on forever. We talked about in the exponential section. All right, so we start at the base. The base is e, so e is my base. Across the equals, so raised to the -5 is equal to, and back again, y. E to the -5 is equal to y. For this last one here, the base is 6, so we have 6. Across the equals, raised to the -2, and back again is equal to y plus 1. It's pretty amazing, honestly, to have a trick that works so well. Because what I want you to notice, the trick not only works in both directions, log to exponential and exponential to logs, but it also works if log is on the right side or if log is on the left side. It doesn't matter which side of the equation log is on, you can use this trick no matter what. Now, I want you to be really careful about trying to look for a particular shape for the loop-de-loo, right? Oftentimes students will try to look for this like shell, it's not really a shell shape, but this like spirally shape here. It makes a spirally shape as long as log is on the left, but if log is on the right, it doesn't make as much of a spirally shape as it does a circle. So just kind of keep that in mind. Let's go ahead and go in the opposite direction. So now instead of going from logs to exponents, we're going from exponents to logs. And the important thing to know here is that when you're writing this, you're looking to fill in log base blank of blank is equal to blank, right? 1, 2, 3, where the base is this number down here. Start at the base, across the equals, back again. So the base here is E. So ready? We have log base E. I have filled in the first piece here. Oh, good. All right, I got interrupted by a phone call there. We start at the base. So we have log base E. Across the equals, so of, now we're on the second part here, so of 5, and then back again, is equal to 2t. Now, this is okay, but really, if we have base E, we don't like to leave it as base E. This is ln right here. So I'm going to write this as ln of 5 is equal to 2t. Noticing that when I write it this way, I don't write ln base E. It's not ln base E, it's just ln. Over here, we start at the base. The base is 8, so we have log base 8 of, across the equal, 64 is equal to, and then back again, is equal to 2. Bam. For here, the base is 10, so we have log base 10 of, across the equal, log base 10 of 7 is equal to W. 10 is the common base, so we don't need to write it. The 10 is unnecessary. So we could write this as log of 7 is equal to W. Log without a base written is base 10. Finally here, start at the base is 1/4. Log base 1/4 of, across the equals, 6 is equal to X. And bam, there it is. I'm going to go ahead and write down a few for you to practice real quick. Not real quick. I don't care if it's real quick or if it takes you a while. You could take your time on it. I'm going to write some practice problems down for you to try, though. All right, here's 5 of each. 5 exponential, 5 logarithmic. I'm not going to do these fully on camera. I'm going to give you a moment to pause the video and practice these on your own piece of paper. And I'm going to pause my own video and then display the answers. But I'm going to give you a moment to pause. I'm stalling, giving you a moment. You know, if you're on YouTube, you can push the space bar. That pauses your video. You've had a moment. You've been warned. Answers are coming up next. All right, and here they are. Here are those answers to those practice problems. For these guys right here, for A and B on the right-hand side, the preferred answers are underlined. All right, so hopefully that was enlightening and fun. In the next video, we will talk about evaluating some logarithmic expressions. I'll see you there. Bye.